This is 4 continued. So last time we talked about solving systems of equations in 3 variables. What I'd like to do now is talk about some application problems, aka story problems. The first kind of problem I'd like to talk about is if you're asked to write the equation of the parabola that passes through the points, say 2, -3, 3, 10, and then 4, -8. So the key thing to remember here is the general equation for a quadratic equation or a parabola is y equals ax squared plus bx plus c. And you'll note that you've been given here 3 pairs of xy's. 2, -3 is one xy, 3, 10 is another xy, and 4, -8 is a third xy. So I can then just plug these in to generate 3 equations, and that'll allow me to solve for my 3 variables, my a, b, and c. So when I plug -3 in for y and +2 in for x, I have a times 2 squared plus b times 2 plus c equals -3. When I plug 3, 10 in, I get a times 3 squared plus b times 3 plus c equals 10. And when I plug 4 in, I have a times 4 squared plus b times 4 plus c equals -8. And that's my system of 3 equations. In this particular situation, I don't really care how you solve it. I just need to see this setup. So I will solve this using a matrix. So I have matrix 4, 2, 1, -3, 9, 3, 1, 10, and 16, 4, 1, -8. How did I get those values? Well, 2 squared is my 4, 2 is the 2, 1 is the 1, -3 is the -3. What I do then is I do the row reduced echelon form on my calculator, and I'm going to get a matrix that looks like this, where this last column is going to be my solutions. So let's show you how we do that. Fire up my handy graphing calculator here. I will start by typing in my matrix. So I'll go to matrix and then edit. I want a 3x4 matrix. And my coefficients are, oops, not that, is 4, 2, 1, -3, 9, 3, 1, 10, 16, 4, 1, -8. I exit out of the matrix menu. I go back to the matrix menu and then retrieve the RREF command. And I do that RREF command on matrix A. So I see that my solutions then, my A value is -15.5, my B value is 90.5, and my C value is -122. Well, I already forgot. Positive. So, plugging everything in, I have y equals -15.5x squared plus 90.5x minus 122. The other type is usually going to be a some kind of money problem or something similar to that. So let's say that we have the following question. A child has $6.17 in change. The change consists of 113 coins. And the coins is a mix of pennies, nickels, and quarters. If there are 8 times as many nickels as pennies, how many of each type of coin do I have. So I'm going to start by assigning a variable for each one of these quantities. P is going to be the number of pennies. N is going to be the number of nickels. And Q is going to be the number of quarters.
Mr. Simmons, please come to the office. Mr. Simmons, come to...
Okay. So I'll first deal with what I'm going to do with this $6.17 and change. So what I know is that a penny is 1 cent. So 0.01 times the number of pennies is going to give me the amount of that $6.17 that comes from the pennies. A nickels is $0.05. So 0.05 times the number of nickels is going to give me the number of nickels, or the amount of money from nickels in that $6.17. And then 0.25 times Q is going to give me the amount of money from quarters that is in that $6.17. So if I add those all up together, that sum should give me the total amount of change I have. Now if I take the number of pennies plus the number of nickels plus the number of quarters, it has to give me that 113, the number of coins total. And now we have 8 times as many nickels as pennies, right? So this is something that kids screw up the equation for all the time. So if I have 8 times the number of nickels as pennies, if I have 1 penny, I should have 8 nickels. So I see then that N should equal 8p. If I plug 1 in for p, I get 8 coming out of it. So I have then N is equal to 8p. So this is my system. Now, rather than solving the system by hand, because we're not asked to do that, I'm going to solve it using a matrix. But to do that, I have to put this p back into the p column. So I will rearrange this system by just subtracting that 8p from both sides. So the first 2 equations stay exactly the same, but that third equation now is negative 8p plus n equals 0. So very important that when you move that over, that you do move the 8p over, and when you do move it over, you put it in the same column as the rest of the p's. That all has to line up in a column. Okay, let's make our matrix now. I guess we could write it down first. Oops, I don't want a highlighter. So my matrix, 0.01 times 0.05 times 0.25, and then 617. And then we have 1, 1, 1, 113, and then negative 8, 1, 0, 0. And we're going to do the RREF on that. And it'll spit out a matrix that looks something like this. And let's just find that last column now. So we'll do that by plugging this into my matrix. So I'll go to matrix and then edit. And then for my 3x4, I'll just type in my system as it appears. And 13. And let's get out of there. Go back to the matrix menu, over to the math tab, select the RREF, and do RREF of matrix. So when that spits out, I get 1296.5. So that tells me 12 pennies, 96 nickels, and 5 quarters. And I'm finished. That should be enough examples to finish this up.